For centuries, humanity has looked at the sun as the unshakable ruler of our cosmic neighborhood. Every planet, asteroid, and comet moves under its immense gravitational influence. Its powerful solar wind races through space at incredible speeds, shaping the invisible boundary that protects our solar system from interstellar radiation. Scientists believed they understood this behavior better than almost anything else in space. But sometimes the universe reminds us that certainty can disappear with a single unexpected observation. Earlier this year, researchers studying information collected by NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter noticed an unusual pattern hidden deep inside enormous datasets. At first, it looked like a simple measurement error. Spacecraft regularly experience interference from energetic particles, changing magnetic fields, and countless environmental effects. Yet the anomaly refused to disappear. Every new analysis revealed the same strange signature. Instead of flowing smoothly away from the sun, portions of the solar wind appeared to bend in subtle but organized ways. The distortion wasn't random turbulence. It formed repeating structures that followed a surprisingly consistent pattern. That alone was enough to capture the attention of solar physicists. Then another discovery complicated the mystery. Astronomers were already tracking a recently identified interstellar object passing through our solar system. Unlike ordinary comets that originate far beyond Neptune, this traveler had entered from interstellar space, making it only one of a handful of known visitors from another stellar system. Initially, scientists expected nothing unusual. Interstellar objects are valuable because they preserve material from distant star systems, offering clues about planetary formation across the galaxy. But this object quickly proved far more intriguing than expected. As telescopes monitored its brightness, researchers noticed that the reflected light changed in an unusually regular rhythm. Most natural objects brighten and dim because they rotate irregularly or release clouds of dust and gas. This object's variations appeared surprisingly consistent. Although several natural explanations remained possible, including rotation, unusual surface composition, or complex geometry, the repeating pattern encouraged astronomers to investigate further. When additional observatories gathered more observations across different wavelengths, researchers began comparing those measurements with data from spacecraft studying the Sun. To their surprise, the timing of certain changes appeared remarkably similar. No one immediately suggested an extraordinary explanation. Scientists instead searched for every conventional possibility they could imagine. Could solar activity be affecting both observations? Was there an instrumental bias? Were computer models introducing false correlations? Each possibility was carefully tested. Meanwhile, the James Webb Space Telescope contributed infrared observations that helped estimate the object's temperature and composition. Rather than providing dramatic answers, the data raised additional questions. The object's surface properties seemed more complicated than expected. Some astronomers proposed that unusual minerals or frozen compounds could explain its behavior. Others argued that sunlight interacting with an irregular shape might naturally create repeating brightness variations. The debate intensified. Back near the Sun, Parker Solar Probe continued diving closer than any spacecraft before it, flying through regions where temperatures soar into millions of degrees. Every pass collected unprecedented measurements of magnetic fields, charged particles, and plasma flowing outward from our star. Once again, researchers noticed subtle distortions that didn't perfectly match existing models. The differences were extremely small. They certainly didn't prove that anything impossible was happening. But they reminded scientists that our understanding of solar physics is still evolving. As independent teams compared observations from multiple spacecraft, telescopes, and computer simulations, they reached one important conclusion. – Something interesting deserved further investigation. That conclusion sparked an explosion of speculation across the scientific community and online discussions alike. Some researchers imagined entirely new plasma interactions never before observed. Others wondered whether magnetic fields around small objects could occasionally produce effects more complicated than existing theories predicted. And outside mainstream science, far more dramatic ideas rapidly spread across the internet. Could the visitors somehow be interacting with the sun? Could an unknown natural process be responsible? Or were people simply connecting unrelated events because the timing appeared coincidental? For now, nobody knows. What makes this mystery fascinating isn't proof of extraordinary technology or evidence of alien intelligence. It's the reminder that space continues to surprise us. As researchers continued studying the mysterious interstellar visitor, one thing became increasingly clear: every new observation raised more questions than answers. Instead of solving the mystery, each dataset revealed another layer of complexity that challenged existing assumptions. Around the world, observatories focused their instruments on the object whenever possible. Visible light, infrared radiation, and radio observations were compared in an effort to understand what this traveler was truly made of. Several scientific teams proposed that its unusual behavior could be explained by an uncommon combination of rotation, surface materials, and interaction with sunlight. Others suggested that gases escaping from beneath its surface might produce effects unlike those seen in ordinary comets. These explanations remained entirely plausible. Yet none accounted for every observation perfectly. Meanwhile, solar scientists continued examining fresh measurements from Parker's solar probe and solar orbiter. Their mission wasn't to study the interstellar object directly, but to understand the Sun's magnetic environment with unprecedented precision. Those missions have transformed our understanding of solar physics. They've revealed hidden structures inside the solar wind, unexpected magnetic switches, and plasma behavior that scientists are still working to explain. Every close encounter with the Sun produces enormous amounts of information, much of which will take years to analyze completely. That is why patience remains essential. History has shown that the first explanation for a surprising discovery is rarely the final one. Many famous astronomical mysteries eventually turned out to have perfectly natural causes once more data became available. Others completely reshaped modern science. No one yet knows which category this mystery belongs to. Still, imagination naturally fills the gaps left by uncertainty. Some futurists wonder whether advanced civilizations, if they exist somewhere in the Milky Way, would rely on technologies that appear almost invisible to us. Instead of giant spacecraft covered with metal, perhaps their creations would manipulate magnetic fields, plasma, or light itself in ways we cannot yet recognize. Such ideas remain speculative. There is currently no scientific evidence proving that this interstellar visitor is artificial. But asking bold questions has always been part of scientific progress. Every generation inherits mysteries from the one before it. Centuries ago, people didn't know what galaxies were. They didn't understand black holes, neutron stars, or planets orbiting distant suns. Today those discoveries are part of everyday astronomy. Tomorrow's textbooks may explain phenomena that currently leave scientists puzzled. Perhaps this object will eventually become another example of an unusual but completely natural visitor from another star system. Or perhaps it will reveal entirely new physics governing how matter behaves in extreme environments. Either outcome would expand humanity's understanding of the universe. What makes discoveries like this so exciting isn't the promise of sensational headlines. It's the opportunity to learn something genuinely new. Every observation collected by space telescopes and robotic spacecraft adds another piece to an enormous cosmic puzzle. Sometimes those pieces fit immediately. Sometimes they remain unexplained for decades. That is the beauty of exploration. The universe owes us no simple answers. It invites us to keep observing, questioning, testing, and learning. As this interstellar traveler continues its journey back into the darkness between the stars, astronomers will keep watching for every possible clue. Future telescopes, more powerful than anything operating today, may one day uncover details that current instruments cannot detect. Until then, the mystery remains open. Perhaps the object is simply an extraordinary natural relic from another planetary system. Perhaps it represents a phenomenon never before witnessed by human civilization. Either way, it reminds us of something profoundly important. Despite all of humanity's scientific achievements, we have explored only a tiny fraction of our own cosmic neighborhood. Beyond the edge of our solar system lies an unimaginably vast galaxy filled with billions of stars, countless planets, and mysteries waiting to be discovered. The greatest revelation may not be what this object ultimately proves to be. The greatest revelation is realizing how much of the universe still remains unknown. And perhaps that endless frontier is what continues to inspire every new generation of explorers to look upward and ask the same timeless question. What else is out there?